So hello you beautiful people. This is the video about the Euler scheme for the autocatalytic reaction, and today we want to do it in MATLAB. So I think I hope you all have MATLAB installed on your laptops or computers, and so what we want to do is create a new script. This means we go here to script, and then we put in a first line, just write clear all. So this means that all variables are cleared and that you don't have some old values inside your variables and so on. And so that we don't forget it, you can just save it, and I put it here in my chemical reaction engineering folder. I have a MATLAB subfolder, and then I call it just AutoCAD. Okay, so this is our new file. And so what do we need for this autocatalytic reaction? We need all the start concentrations. So let's say, for example, C1 is equal to 0.5. So in MATLAB, you have to use the decimal dot instead of the what is it, colon. So if you write this doesn't make sense to MATLAB, and that at the end of your line you always have to put a semicolon. This means that it's not sent to the prompt, to your command window. So your code, you can run your code here. If you say run, then you would see, okay, the start concentration is 0.1, but we don't want to know it. And then if you want to comment something, then you can say, so here you can maybe write, this could be in kilomole per cubic meter. Okay, then start concentration for component 1 could be 2. This is again in kilomole per, and the 3 we say this should be 0. And again in kilomole per. What do we also need? We need the K. So here we can put, like in the example I showed you in my slides, this could be 0.05. Again the semicolon, and oops, in what should be the rate? It should be divided by minute kilomole. Some weird units have to be there. Okay, then we have to define our delta t, the time step size. Here we say, I don't know, let's say 1.5 minutes in minutes, and we need like a t end. Let's say 60 minutes. Okay, and then we have to say, okay, our concentration. So MATLAB is working always on a vector basis. So MATLAB, everything is related to matrices and vectors. So here we say, okay, this C1 will become a concentration vector, and the first value of this vector, this will be the start concentration. So maybe I will switch to the command window. If you say, okay, I want a new vector A, and it should be 1, 2, 10, 15, something like this. Then you have a vector here, and then you can say, okay, A1, this means the position 1 in our vector. If I say A3, this is again A. So A3 is 10, and then A3, you can see this is the 10. Okay, And we do the same for our start concentration, C3. And we also define a time vector, and this should just be 0. So this means what we have right now, we have like 4 vectors, and the vector only have one value inside it, and so this is all our start information. And what we do now is that we create like a big loop where we can calculate the values, so the next things here inside our concentration vectors. So for this we just say, okay, let's start it with, we already have 1, let's say, okay, it should start with, yeah, it should start with 1. Then we say, and it shall end at t end divided by delta t. So if we say, okay, the end should be 60 minutes and we have a step size of 0.1, then here this will go, oops, I forget the I. So you create here a new counting variable I, and this should go from 1 to basically 600. Whoops, and here I did some writing mistakes. It should be this Tn divided by delta t. So this for loop, you will finish it with end. So very simple. And so what do we need to do now? We have to calculate our reaction rate. And our reaction rate is just the value of K times the concentration 1 at our, so if you started with 1, so it always has to be the counting value of I times C2, whoops, caps lock, C2 I. So now we knew our I, and then we can go for delta C1. I is, so C1 is increasing. This means it's plus Ri times delta T. If you look at the slides, there you will find the according equations. Delta C2 I is decreasing, so it should be minus. So minus Ri times delta T, and delta C3 I is plus Ri times delta T. So now we know the old concentration, we knew the change in concentration, and with this we can calculate the new concentration. So this C1, and now we write I plus 1, so this means the next value in our vector. This should be the old value in our vector, so the previous time step plus delta C1 at the position I. And this we have to do for all 3 components. Plus 1 is equal to C2 I plus delta C2 I C3 I plus plus 1 C3 I plus delta C3 I. And we also have to increase our time. So time I plus 1 is times I plus delta t. Okay, so, and if you look at the slides I showed you about the Euler scheme, you need your starting values. If you have this, then you can calculate the reaction rate, then you can calculate the change in concentration, and then you can calculate the new concentration. And this is what we've done here. And if everything works out fine, then we can plot it. So if you want to plot something, then it makes sense to say in which figure it should end. So this is just MATLAB is giving to every figure it's giving a name. So you just say figure 1, then you say okay, plot, and then you want to plot t on the x-axis, and you want to have, for example, C1 on the y-axis. And then if you want to have a legend afterwards, you can say this is display name. Then you can say here like a name, you could say C1. And then what is special about MATLAB, if you would just write beneath it the next plot command, then the first one would be deleted. So you have to say MATLAB, okay, I want more than just one plot to be in the figure. So you say hold on. This means can now plot the other concentration. So it's C2 and our concentration name should be C2 and again C3. Then you can say you want to have a legend, and you can say MATLAB, okay, where should this legend be? You can say it with location, and then you use the annotation of a compass. So you can say maybe, I don't know what is a good idea, maybe you should have it in the northwest. Okay. Then if you, oh, maybe we can have a look if it works so far. Okay. Then you just press run here. Okay. What's happening? 23. Yeah. It was a minus instead of a. My writing is so bad. Okay, this is a capital C. It's also a mistake. And here you can see how it looks like. So we have here the C2. This is going down. C3 starts at 0 and it will go up to here. And C1 starts at 0.1 and it will go to 2. No, it's not going to. It's not the end value already. Okay, so what is so convenient about MATLAB? If you see, okay, it's the reaction is not it's not finished. Maybe you can just double the time, say 120, and then you can see, okay, another mistake. I forgot to delete the old plot, and this can be done with CLF. This means clear figure. CL for clear and F for figure. And if I run it again now, then you only have this 3 lines in here. Okay, so for a good scientific plot, you need also a label of the axis. This can be done with X label, and this should be time in minutes, or we can write time t in minutes. Y label is concentration CI in kilomole per meter cubed. Okay, let's see if this works. Yes. So what you can see here, you have the 1 and the 2 and the 3 you have as a subscript, and here you have it elevated. So this, you can do this with I don't know, this is the like this triangle or whatsoever, and if you want to have a subscript, then you just put this this, I don't know what it's called, underline, you put it here, and then you have it. Okay, this is what our figure 1 looks like right now. Maybe you think it would be nice to have something like a grid, then you can just write grid on. And now you have here some grid lines if it's more convenient for you. And you can very easily play around with it. If you say, okay, I want this concentration to be really low, then you will see that it takes quite a long time, and you can hardly distinguish C1 and C3 because they are almost the same. So let's go back here to this value and run it again. So now it looks better, I would say. Okay, so here our legend is not very nice. If you want to change it, you can say, okay, let's put it on southeast. Southeast. I think this is clear. You all know the directions. Maybe then you can put it like this. Okay. Yes. What else can you do? You can play around, of course, with the start concentration. If you say C3 shouldn't be 0, but it should be like also 2, maybe. Don't know why you should operate a reactor like this, but this will also work. Then you have like this fancy curves here. Let's go back to 0 and run it again. Okay, but now maybe we are interested in how good our solution is. And for this we have the analytical solution that I showed you in the slides in the first video. There we have like, let me see, I have to get it. Here we have this expression, and now we can try to, let's say 1, and you can give it funny names, something like this. So C1 for analytical, and this would be, let's put a big bracket, C10 times bracket again C20 plus C10, and then you have to divide it again, don't forget the bracket, C10 plus C20 times exponent minus bracket C20 plus C10, close the bracket, times K times T. So And what is the good thing? We have here this t is the vector for the time that we already defined. So we will end up with a concentration vector for the analytical solution that has the correct size and has all the same values. Okay, and then I think we have to close two brackets, and hopefully this works. Okay, then let's plot it, or we can plot it here. Plot t C1 analytical, and the display name should be C1 and then in brackets analytical. Okay. Hopefully I didn't make any typing mistakes. Oh, I did. Okay. Then maybe it's a problem with the vector. Let me try the dot here. Yes. Okay. So this is because MATLAB is doing this vector operation. And do I have my A vector here? No, I wrote clear all. Okay, A is 1, 5, 10, 15 or something like this. Okay, so now I have this A vector again, and then if I say okay, I want every entry here in this vector, or I want a new vector with, so every number here should be 1 divided by this number. Then if I just write 1 divided by A, then it's not working, because then MATLAB tries to do a matrix operation, which is not properly working. But if I say 1, then a dot, and then this means that you do it for every element. So A, remember this, so A, the second entry is the 5, and if I divide 1 by 5, then it should be 0.2. If I divide 1 by 10, then it should be 0.1, and so on. And that's why I forgot this dot here. If you do it, if you put it there, then everything is fine. Okay, let's have a look at our line here. And you can see that C1 analytical is nearly matching our other curve. Yeah, very identical. So, but this is so you cannot see how good the agreement is. So for this, maybe you can try to have a new time. Maybe we can also call it t analytical, and we can define a vector for it. So let's say we want to start with 0, then we want to have like a time step of maybe 10 minutes, and it shall end at t end. Then we can divide it here, and then we don't use the time from here, but we use the new time that we just defined. So let's call it t analytical, and this should work normally. Vectors must be the same length. Why is it not working? Ah, didn't change it here. Stupid mistake. Of course, I have to say that it should be the analytical time that we need here. Okay, and so here you can see that it's not looking that good, but we don't want it in lines, but maybe it would be enough to just have it as a symbol. So, and if you want to have it as a symbol, you can say, okay, maybe use a circle for it. Then you just put in here, after you say the vectors that you want to plot, you put here a symbol. So this should be small circles. Okay. And now you can see that the agreement is really, really good. So if you don't want to have the circle, but you want to have small squares, then you can write an S, and then you have small squares. So very useful from my point of view. You don't have to go to the internet and do something. You just can type help plot, and then you get the help, and you will find here an overview about how you can modify the colors, how you can modify the symbols, and how you can modify the line style. So if you say, okay, I want to have I don't know, red triangles down, then you write here, instead of S, you write red for the color and V for triangle down, and then you have it like this. Okay, another thing we can try is, I told you that the size of delta t is important for the error of your calculation. So if we increase our delta t by a factor of 10, let's see how good the agreement is right now. Okay, maybe there are small deviations here, but it's not that easy to see. Okay, let's increase it to 5. And now you can see that here you have deviations from the analytical solution and our numerical scheme. So this means a step size of 5 minutes is way too big. So it should be, I think 0.1 wasn't such a bad choice. Okay, so there are really a lot of things I could tell you about MATLAB. So you're never finished with MATLAB, and yeah. But I think you have this numerical mathematics, and there you use MATLAB a lot. So this is just as a first introduction to this thing. Okay. Don't forget to save it. Just click here, save, and basically this was the Euler scheme for the autocatalytic reaction. And yes, hope you enjoyed it, and maybe you can try it on your own. Goodbye.